Hello and welcome back. This is Terrence Fagan, and this is part 2 of a 2D equilibrium problem with a bar, a pin joint, and a string. If you don't remember last time, or if you go back to the previous video, we found out that this here is interestingly equal to 0. So we can actually go back to our free body diagram and cross this out. So what does that mean? Well, that frees up some other equations. So we can't use this equation anymore. We can't use the sum of the moments equals 0. But what do? Well, we have two other equations to deal with. So this is our next way, or our procedure to how to do that. So if we take the sum of the forces in the x direction, we're still left with FAX and TX, basically. We can break this down into two different components, TX and TY. They're still unknown. Can't really do anything with that. So the only other alternative for now, or the best alternative for now, is sum of the forces equal y. So if we do that, we have a ty. Oops, let's put the sum of the forces in the y direction is equal to 0. So we have ty minus, so everything in the positive y direction is positive, minus f equals 0. Therefore, that ty is equal to, in this case, f, which is indicated by 60 pounds of force. It doesn't tell us what t is, though. Now, here's the thing. With this, we can set, so that's what we have now. But we want to say, if we want to break this up into components, here's one thing we can do. So we have another little drawing here. We could say that that is Tx. This is Ty. And this is T. Furthermore, we know the slope of this, so it goes up A, and it goes over B. That means, and what's A and B? A and B is 3 and 4. So I think B is 3. Oops. That's a cross up. That's a 4. So B is 4, and A is 3. And that means that's a special triangle, and that lines up with a triangle that is equal to 3, 4, 5 triangle. All right. Now, a lot of people want to put the angle here and everything like that, but let's look at how to do it differently. So if I know the slope of the triangle, it's going to be 3 and 4. And I know Ty is equal to 60 pounds of force. The relationship's the same, so I can say that 3 over 5 is equal to Ty over T, where this would be T. These here are similar triangles. That's a very powerful tool. You're going to, if it's given the slope or you can figure out the slope. A lot of times it's easier than to figure out all the angles, because the angles are just, for mechanics, it's just length ratios. That's all it is. So if we solve this, and we continue down here, and we can say that T is equal to 5/3 times Ty, we know we can figure out what T is. So in this case, we can say it's 5/3. That's 60 pounds of force, and we don't even need a calculator. This goes to 3, that goes to 20, 20 times 5, and we get 100 pounds of force per T. That's what we wanted for T. So now we have our first variable that we wanted to solve. So yes. So next, we can use, well, we've used already the sum of the forces in the y. We've used some of the forces in the sum of the moments, but let's go with some of the force in the x. So what we can do is down here, we can say that the sum of the forces in the x direction is equal to y. So if we go back up, we can say that FAX minus TX is equal to 0. We don't know TX, but we can figure that out pretty quickly. We know FAX and TX is the same. But remember that triangle. Have that triangle. We know it's I think it's a 4, 3, 5 triangle. We also know it's very similar to this vector component Tx, Ty, and T. We could do the same thing over Tx. So we'd say that Tx over Ty is equal to 4/5. Now, you can figure this out, and Tx is actually equal to 80 pounds of force. Again, this is one way to do that. You can always generalize and do this in vector form and find the unit vector, which is fine. And then move on from there. This is one way to do it. We use similar triangles. So let's sum it out. So we have all the answers. The answers again, we sum up, we can know that T is equal to 100 pounds of force. And we also know that FAX, or FA, because FAY is 0, is equal to 80 pounds of force. If we want to put it in vector form, that's a different style, but it didn't ask for vectors. So that would be our answer to this problem. This is part 2 of a 2D equilibrium problem. Have a great day and see you soon.